Hello, this is Captain Chaudhari. Today I am going to speak to you about visibility. I often ask students what is visibility, and you'll be surprised how many different answers I get. I can write a book on what is visibility. The most common answer that I get is visibility is how much you can see with your naked eyes. What they mean is how much you can see with the bare eyes without binocular or without any equipment attached. To a certain extent, this answer is acceptable, but it is not acceptable also. Now, in our field, there is a little bit of a technical aspect in every definition. So we shouldn't forget it, that we can't just give casual definition. What is visibility? I often tell them, if you want to define visibility in a shortcut, then you should say visibility is transparency. It is the transparency of the medium. Clear glasses, then you have frosted glasses, then you have the glass that is not so clear, it is kind of opaque. Now imagine a glass which is absolutely crystal clear if it is stretched from sides, not breadth-wise, the depth-wise. If the glass is stretched, what you see on the other side is the transparency of the glass. Remove the glass and you have the air and atmosphere in front of you. What is the transparency of the atmosphere? I tell the student, no, I want the meteorological visibility as is defined in Admiralty list of flags. So, remember one thing, the visibility defined there is actually visibility in horizontal direction. Visibility in horizontal direction means how much we can see in the horizontal direction. That's not the correct definition, because in horizontal direction we see moon rising, we see sun rising. We can't say the visibility is 93.4 or 94.6 million miles because I can see the sun rising. Visibility is defined for an object which is unlit. It does not have a light of its own. It is also a dark object which is not actually reflecting the light from other source. It should be dark object seen against light background. Now, dark object seen against light background is also not a complete definition, because if there is a dark coconut, I can't see it more than 1 mile off, maybe half a mile off. So it is a dark object of appropriate size, reasonable size, as can be seen against light background and can be distinguished very clearly against that background. So I shouldn't be saying whether it is a cloud or an island. Visibility is defined in horizontal direction. It is defined as how far a human eye can see a dark object of reasonable size against light background and can be clearly distinguished. So that is meteorological visibility. So how do we understand meteorological visibility? How do we understand practically the meteorological visibility? So meteorological visibility, if you want to find out in daytime, if you're navigating with radar on, while coasting particularly, then when is the first time you see a dark island or a mountain against light background that is of light sky? You must note down the distance. That is the visibility in that direction. Now visibility is defined in daytime. So what is visibility in nighttime? From the way I am describing, probably you might have guessed that visibility is because of meteorological conditions. We confirm that meteorological visibility is 10 miles in daytime, and suddenly the night falls. Visibility in daytime or nighttime would be 0, probably because of thick fog. So in nighttime, if background light is equivalent to daytime, then how far you can see, again the same dark or black object of reasonable size, that would be the visibility. So now, select a day on which you could see an island just about 10 miles off, and you could clearly say that yes, this is island, this is not the cloud. That means the meteorological visibility is 10 miles, and suddenly night falls. On such night, when meteorological visibility was 10 miles, there was a lighthouse which could be seen at a maximum distance of 15 miles. So 15 miles is its nominal range, the range that is marked on British Admiralty chart. So now suppose there is a light, purely because of its candela power, it cannot be seen beyond this distance on the night when meteorological visibility was 10 miles. So this is meteorological visibility 10 miles, this is the nominal range. As you know, light does not travel in a perfect horizontal direction. It, because of refraction, curves towards the surface of Earth, and it, in the process of traveling in a curved path, touches a distance or tangents the surface of the Earth at a distance given by 2.095 under root height of light in meters. So if the visibility is perfect or crystal clear, let us see what is geographical range. We are talking about geographical range, or we are talking about rising or dipping of a lighthouse. Rising when we approach the light and dipping when we go away from the light. How to find that distance? So suppose there is an island with a light traveling because of refraction in the curved path, and thereafter, after curving further, it reaches the wheelhouse of a ship. Yes, wheelhouse of the ship. The height of eye over here is say 16 meters. Height of eye of this light is say 25 meters. Now the distance from here to here is 2.095 under root 25, and distance from here to here is 2.095 under root 16. So this is 4 and this is 5. So 2.095 multiplied by 5 plus 4, that is 9. So that is about 18.455 miles is the raising distance of this light for this ship. The ship having height of eye of 16 meters and the light with the height of light as 25 meters above the water level. So 18.455 miles is the geographical range or raising dipping distance. Geographical range is 18.45 miles, but there are various other factors which will decide whether I can see this light 18.45 miles off when I'm approaching or not. So at the moment, let us assume that the height of eye is 16 meters, height of light is 25 meters at this water level, and geographical range is 18.45. Now, the nominal range of the light is 16 miles, but unfortunately, on the evening or night when I am approaching this light, the meteorological visibility becomes 5 miles, falls to 5 miles. So what I need to do is, I need to look at the luminous range diagram. Now, luminous range diagram is given for various meteorological visibilities like 2 miles, 5 miles, 10 miles, 20 miles, etc. Now, along the x-axis, you have the nominal range from where you can enter the graph. Now, on this side, you can read is present visible range or present luminous range. Now, nominal range of the light is 16 miles. I drop perpendicular on 5 miles visibility because present visibility is 5 miles. From there, I turn left. I come and read the value of PVR or PLR on y-axis. This happens to be say 9.6 miles. This means that in present visibility, you will not be able to see the light more than 9.6 miles off. This is provided the meteorological visibility is 5 miles. Of course, this distance which we are talking about, 9.6 miles, is not to be considered reliable for plotting the positions which are crucial. That is because we are assuming that the visibility is 5 miles, but it may be different than 5 miles. So this is just for reference. This method of finding out range is just for reference, just to know that in a port, if the visibility is 5 miles, how far I will be able to see the light, only for that purpose, and not for plotting a position and banking on that position, right? So what I have found out now for the ship, that the geographical range for the light is 18.45 miles and present luminous range is 9.6 miles. Let me draw a bigger diagram to understand these things together. So here's the curvature of the earth. Here's the island, the light. Now the light is traveling in a curved manner. Here's the wheelhouse of the ship that is approaching. The distance is 2.095 under root height of light in meters plus 2.095 under root height of I in meters. This is geographical range. This is also called raising or dipping distance. Raising distance when you are approaching the light, and dipping distance when you are going away from the light. Nominal range of the light is so much. That means if the meteorological visibility was 10 miles off, you would have seen the light so many miles off. Okay, that means geographical range is good enough. So if the visibility was 10 miles, then I would have picked this light how many miles off? I would have picked this light 16 miles off. So meteorological visibility 10 miles. The first sight distance would be 16 miles, which is the nominal range. If the meteorological visibility was perfect, or say 20 miles, then the first sighting distance would have been 18.45 miles. But now meteorological visibility is 5 miles, which means the present visible range or present luminous range is 9.6 miles, which means the light cannot be seen beyond this distance. So if the visibility was perfect, I would have seen the light 18.45 miles off. If the meteorological visibility was 10 miles, I would have picked up the light at a distance of 16 miles. But meteorological visibility is only 5 miles. And for 5 miles, the visible range of the light is 9.6. That means when I see the light for the first time, the distance would be 9.6 miles. If you have understood this diagram and the explanation, then let us see what we should do when the same thing is asked in the examination. In examination, when question says that the light was first sighted or last sighted or first seen or last seen, when this particular term is used, then we must find out the PLR or PVR from the luminous range diagram, and we should find out the geographical range by the formula, and the smaller of the two would be the distance at which the light is first sighted or last sighted, first seen or last seen. But if the question says that the light was raised, then we don't have to see the luminous range diagram, and then straight away we will use the formula 2.095 under root height of I plus under root height of light in meters. Why? Because the question specifies that the light was raised or dipped. So candidate must write, since the question says the light was raised or the light was dipped, I am using the formula to find out the geographical range, and I assume that the visibility in the direction of light was good enough for the light to be raised, and that's why I am taking the raising distance. Now, some old-timer masters, they tell the candidate in misty visibility also, they tell the candidate, look, the visibility is not good, you will be able to see the light in that direction, let me know when you raise the light. They are using the term, let me know when you raise the light, but that actually means let me know when you first sight the light, because raising is not possible unless the visibility is crystal clear. It is rare to see an object rising above the horizon in the daytime because your visible range normally is limited in the daytime. But if your visibility was say more than 20 miles on a particular day and you were approaching this port in the daytime, let us say it was blue seas, blue calm seas and crystal clear visibility, and you happen to see the lighthouse coming literally above the horizon because you are approaching the port, then you could have said that in daytime you are raising the lighthouse. The phenomenon is rather rare. But nighttime it is not uncommon to raise a light or dip the light. How do you raise a light in the nighttime? You are approaching the port, and let us assume once again that the visibility is crystal clear and meteorological factors are favoring you, and then you see a loom of light, approximately at the point where you want to raise the light, and thereafter a kind of small tiny bulb rises on the horizon slowly and gradually. That is called raising of the light. Whereas if the master in a misty visibility asks a lookout person to keep a sharp lookout in a particular direction, because you would be seeing the light there, and suddenly that flashing light is seen for the first time, then you would say the light was first sighted. So normally light first sighted is more applicable in a visibility which is less than normal, and a light getting raised or dipped is more common in the situation of very good visibility.